In this video, I will be finding the pivot columns of this matrix. So in order to find the pivot columns, we reduce this matrix into a row echelon form or a upper triangular form, and we take the first non-zero entries of each row. So let's start with the top left. We'll use this guy as a pivot, and we need to cancel out everything below it. So we can take this third row and add the first row to it, and then we can take the fourth row and subtract 2 times the first row. So let's do this operation. The first row stays the same, second row stays the same. We get a 0 right here, a 4 right here, a -4 right here, a 0 right here, and a 5 right here. And then we take this row and subtract 2 times the first row, so we get a 0 right here, a -5 right here, a 1 minus a -4, so a +5 right here. And then we have 4 minus 4, which is 0, and 1 minus 10, which is -9. So far we have one pivot, and now we move on to the next pivot position, and we'll use this guy as a pivot, and we'll knock out everything below it. We can do that by taking the third row, and we can subtract 4/3 times the second row, and then we can take the fourth row, and we can add 5/3 times the second row. So let's go ahead and do this operation, and what we get is 1, 3, -2, 2, 5. First row stays the same, second row stays the same. The third row, so we're taking row 3 and subtracting 4/3 times row 2. So we have a 0 right here, and then we have 4 minus 4/3 times 3, which is a 0. And then we have -4 minus 4/3 times -3, which is also a 0. And then we have 0 minus 0 and 5 minus 8/3, which is 7/3. Then we move on to the fourth row, and we have a 0 right here. We have -5 plus 5/3 times 3, which gives us 0 right here. And then we also get a 0 right here and a 0 right here. So we have a -9 plus 5/3 times 2, which comes out to be -17/3. So we've just finished using this pivot and cleared out everything below it. So we go to the next pivot position, which is right here, but this is a 0 entry, and everything below it is also 0, so there's no row to swap with. So instead I have to go over another column, and I have to use this as a pivot, but we have the same problem here, so I've got to go over again, and I can use this as a pivot, and I will eliminate the -17/3 below it. And the way I can do that is by taking row 4, and I will add 17/7 times row 3. And when I do this, we get the following matrix. And now we get 0, 0, 0, 0, and this operation cancels this last one out to 0. So our final reduced matrix as a result of Gaussian elimination is this. And recall that we used this guy as a pivot, this guy as a pivot, and this guy as a pivot. And if we look in this row, this last row, there is no pivot that we can use in this row because all of the columns have zeros in this row. So we can look at the columns now, and we find each column that contains a pivot, which are the first, second, and fifth columns. So we come back to our original matrix, and our pivot columns will be the first, second, and fifth vectors.